Hi everyone, my name's Dimity Miller, and in this video I will introduce our paper, Class Anchor Clustering, a loss for distance-based open set recognition. This work was produced with my co-authors, Nico Sunderhouf, Michael Milford, and Faraz Dayoub. Open set recognition extends multi-class classification to open set conditions. Along with the known training classes, a classifier also encounters object classes that were not present during training, or unknown object classes. The classifier must be able to A. correctly classify inputs that belong to a known training class, as well as B. rejecting inputs from unknown classes. One approach is to use distance to identify and reject unknown classes. This assumes that known classes form tight, distinct clusters in the logit space of a classifier, and unknown classes will fall far away from these clusters. By measuring the distance to the cluster centers, these unknown classes can be rejected. Our paper introduces a new loss that improves the performance of distance-based open set recognition. Previous distance-based techniques use networks trained with the standard cross-entropy loss. Cross-entropy loss does not encourage known classes to form tight clusters. We propose our class anchor clustering loss, which trains known classes to cluster around anchored class centers in the logit space. Of these state-of-the-art distance-based techniques, our work is the first to train with a distance loss when also using distance during testing. To demonstrate the importance of this, we show this example where we train a network to classify the CFAR 100 bicycle, train, and bus classes. On the left, we will show the logit space of a network trained with cross-entropy loss. On the right, we will show a network trained with our proposed class anchor clustering loss. After training, we can observe the position of our known classes, as well as two unknown classes, bear and possum. The network trained with cross-entropy loss shows inflated known class clusters, making it difficult to use distance to distinguish the unknown classes. In contrast, the network trained with our class anchor clustering loss shows tight, separated known class clusters and an improved distinction of the unknown classes. I will now briefly describe our class anchor clustering loss and how it encourages clustering in the logit space. We begin by defining a set of anchored class centers in the logit space, one for each known class. These centers are placed at a point on its class coordinate axis, which is equivalent to a one-hot vector scaled by alpha. We refer to these class centers as anchored because their position is fixed during training. For a given input, indicated by the blue circle, we then have an anchor loss term to penalize its Euclidean distance to its ground truth class center, in this case, the blue cross. This encourages the input to map closer to the ground truth center. We also use a tuplet loss term, which maximizes the input's margin of distance between the ground truth class center and all other class centers. This should again encourage the input to move closer to the correct class center, while also moving further away from all incorrect class centers. Our final class anchor clustering loss combines the tuplet loss term and a weighted anchor loss term. During testing, we identify unknown inputs with rejection scores, which multiply an input's distances to the class centers with the inverted softmin of these distances. To get a low rejection score, an input must be close to a ground truth class center while also maintaining distance from all other class centers. By training with a distance-based loss, CAC was able to outperform all existing distance-based approaches on the benchmark datasets. In addition to this, CAC was able to maintain the classification accuracy of the standard cross-entropy loss. Our results also showed that our proposed anchored centers outperformed centers learnt during training on object-based datasets and with higher numbers of known classes. For more detailed results, please see our paper.